Welcome to NARSA Ideas Lunch and Learn webinar series. This is the first webinar that we have done, and my name is Mark Taylor, and I'm the Executive Director of NARSA Idea. For those of you who don't know me, before becoming Executive Director of NARSA, I owned a radiator service business and distribution business for 36 years. So not that experience makes you an expert, but I do have a little bit of experience in measuring radiator cores, and I wanted to share that with you today. Everyone's microphones are muted, and you can post questions on the chat, and don't worry, because I will answer even if you post questions early on in the presentation. I will answer all the questions at the end, and hopefully we'll have time to get to everybody's questions. Today's webinar is sponsored by TSM, Thermal Solutions Manufacturing. TSM has one of the widest variety of radiator core patterns in the industry, and these radiator cores can be built at 3 of their locations that are located across the country. So thank you to TSM for being the first to sponsor a webinar. We really appreciate your support. The purpose of today's webinar is more than just measuring a radiator core correctly. I wanted to talk a little bit about when the radiators come into your business, and about putting a quote together, being able to quote your customers, do it quickly and efficiently, and then be able to order the correct core. So that's kind of the path that this presentation is going to take today. One of the things that I was always big on in my business, and really stressed to the people that I worked with, was to come up with proven processes, a way that we could take and duplicate our results time after time, and be able to have a good outcome, positive results. And so that's the way that I approached business, and that's the way I approach measuring radiator cores, is coming up with this proven process. We want to make sure that we get the right core, or the core ordered right correctly the first time, because we are the professionals. And so if we're not able to do this, this tarnishes our reputation as professionals, leaves a bad taste in the mouth with your customer. It also creates problems with the manufacturer and you. And so we want to discuss ways that maybe we can make it all a positive experience for you, the manufacturer, and your customer. In addition to measuring the radiator cores, we will cover measuring bolt patterns, doing bolt pattern layout. We'll identify and measure notched corners on the radiator core. We'll do some baffle layouts. The one thing that we probably won't have time to do today is going to discuss measuring crank boxes. But if we get through the rest of it, we'll be doing pretty good today. Finally, we will cover then the 12 mistakes that 3 of the manufacturers I spoke to told me that their customers made, that they're the same mistakes that keep happening. And so at the end of the presentation, when we're wrapping up, I'll go through those 12 mistakes. We're going to cover the operations that go into what these mistakes are about. But I think it's imperative that everyone knows what the mistakes are made, the mistakes that are made, and the ones that are made frequently and keep showing up for the manufacturers. So Radiator cores are made up of the same components today that they were 25 or 30 years ago. And today we're only going to talk about copper and brass radiator cores. Well, not just copper and brass, but copper and brass, brass and brass, and steel and brass radiator cores. So the typical type of radiator core that you would get in your shop that would be maybe in an older truck application, a piece of equipment, heavy equipment, genset radiators. So we'll quickly go through a review on what the parts are. I have some components here. I have pieces of a serpentine louvered fin. I'm hoping that you can kind of see this. Here are some flat plate fins. This one's just a copper flat fin 4-row. Here's another plate fin. It has a dimple pattern. Don't know if you can see those dimples. Here's a flat or a plate fin that is louvered. You see the little cuts that are in the fin. And here's a steel fin. Now I don't have samples of brass or solder coated fins, which are options that you can use or choose when you're ordering cores. The radiator core, when it's built, it's baked at the factory, and the solder that are on the tubes bond to the fins, and then the header plates, which this is a bolt-on header, are assembled to the radiator core, and then of course all the tube to collar joints are soldered. And that's the way radiators have been made for years. Some of the other components that you can find on a radiator are side channels. This one is a C channel. This is a box channel. You see how it has another bend on it. Also have a GM type side rail on this radiator right here. Some of the other terminology is that they're for soldered together headers. There's a drop seam, or a groove, as some people refer to it, that's stamped in the header plate. We also have a flat header with a turn up, referred to as a pan header. And then there's also a straight groove with open ends. I have a tube sheet here that this shows a dimple tube. Very important to recognize, and I don't know if you can see this because there's plastic or tape over top of it, but there's dimples in this tube. This tube, so this is a 7/1000 tube, this is an 8/1000 tube, and this is an 18/1000 tube that could be used for high pressure oil cooler applications. The other thing that I don't have to show you are the different diameters of tubes that are available. Later on, when we're filling out a core order sheet, the core order sheet has all the different sizes of tubes, but tubes come in 3/8 diameter, 1/2 inch, 5/8, and 3/4 inch tubes. The larger the diameter of the tube, usually the heavier the tube is going to be. With solder together radiators, which is what this radiator core would be, there are the several variations of the headers which I've already outlined. But we also want to make sure that we identify any type of core supports. Here's a corner support. There's a full header or a picture frame support. In this case, it's a picture frame because it's only on the outside tubes. We also have two different thicknesses of header plates here on this bolt together. We have the this header on the top here where my hand is a heavy header, 0.125, and this bottom header is an 050 header. So that pretty much covers all the different components and types of headers that we're going to deal with today when we're measuring radiators. Before we get started on measuring anything, there's a couple of things that you need. One of them is a tape measure, and it needs to be at least 10 feet long. This is a 25-foot tape, but I like it because the blade is wide and it's easier for me to read the marks. And you only need to go down to a 1/16 of an inch. No increments smaller than that. It's too confusing. You need a caliper, preferably a digital caliper. You can use a TIG rod that's cut for measuring the depth of a radiator. We'll slide that through. Or we have fancy ones that slide back and forth that you can measure the thickness of a radiator. And then also there is a radius device that will allow you to determine what radius you have on your headers for a solder together radiator. One of the things that I have done is that I have taken a dime and I have marked 3/8 on that. I have a quarter and I marked 1/2 inch on that, and a 50-cent piece is the 5/8 radius. So these match up to the radiuses here on this radius gauge. So if you don't have a radius gauge, remember a dime is 3/8, a quarter is 1/2 inch, and a 50-cent piece is 5/8. Now we're ready for the next steps. When a radiator comes into your service business, you need to have a process that will allow you or your people, your operation, to identify if that radiator is going to need a new radiator core. And if you notice, I say new radiator core, not a recore. Recore does not describe what your customer is getting. We learned a long time ago, I had a radiator core manufacturer tell me that it's a new radiator core, not a recore. And I taught my people, and in our company, we used that terminology because people were better able, I think, to understand that they were getting something new when they got a new radiator core. That recore is kind of ambiguous. So that's the terminology that we use and that I'm going to use today is new radiator core. So when a radiator comes into your shop, if there's a great deal of fin deterioration, it makes it easy to immediately identify that radiator as needing a new radiator core. If the radiator comes in and it doesn't appear to have fin deterioration, probably pressure washing, flushing the radiator, and pressure testing is necessary And then depending on what your company has outlined for your processes and procedures on what would require a radiator core, or maybe what you would choose to try to fix, repair, or rebuild, then those procedures can be followed. But if you come down to that, hey, you know, the headers are leaking completely, all the tube to solder joints are compromised, and it's really not worth doing this, we need to sell a new radiator core. So let's talk about that. The radiator's in your shop, you've identified that it needs a new radiator core. What are the next steps? Well, most of the time you have to give your customer a quote. I mean, every once in a while you'll have the really great customer who says, do whatever it takes, I don't care, I just need it back right away. But most of the time, there's going to be a process, a quoting process that's going to need to be followed in order to get the customer's permission to install a new radiator core. So how do we accomplish that? Well, you don't have to take all the dimensions that you would need or verify everything you would need to order the radiator core. We want to be efficient. We want to be quick, efficient, and accurate with the pricing, but we don't need every particular about the radiator core. So what we would do is the service manager, once he was notified, or the service writer, once he was notified that the radiator needed a new core, is he would go and inspect the radiator, and he would take the dimensions, the measurements that would determine what core would need to go into that, what new radiator core would need to go into that radiator. And it's not everything that, like I said, it's not everything that you need in order to be able to order that radiator core, but it's enough information that's going to get you the right core design, the right amount of material that it's going to take to build that radiator, and it's going to give you an accurate price from the radiator manufacturer as to what that replacement core is going to cost. So some of the things or some of the items that you're going to need to, some of the information that you're going to need to be able to quote that radiator core is determining whether it's a flat fin radiator or a serpentine radiator core, the tube centers that are required, the height of the radiator core, the width of the radiator core, the depth of the radiator core, the number of rows of tubes in a radiator core, tube pitch or tube centers, tube diameter, whether it has dimple tubes or smooth tubes, and the fin material, fin gauge, and fins per inch. So once you have those items, then you're able then to determine the type of core that you're going to need to order. And I always recommend apples to apples. So when you're measuring a radiator core and you know, you have 1/2-inch tubes on 5/8 centers, and you know, 4 rows of tubes is 2 3/8 of an inch thick, that's a standard flat fin or plate fin radiator core, then it's easy to determine where you can buy that core, and you call the manufacturer and you get the price, you get a quote number, and then you're able to quote your customer. If it's a bolt together, now that would be for solder. If it's a bolt together, you need the gauge of the headers and whether or not it has full reinforcement, corner supports, picture frame reinforcements, the gauge of the headers, because once again, remember that the price of a radiator core is determined by the amount of material that it takes to build it. The core manufacturers are buying tubes by the pound, they buy copper strip by the pound, they buy the brass plates or the brass strip by the pound. And when they build a radiator core, certain core thicknesses and then heights and widths, which they use usually a square inch chart of some sort, all this is, the price is all determined by the amount of material that's going to go into building that radiator core. So you want to make sure that when you're doing these specifications and measuring these radiator cores, that you're accurate so that you don't get any surprises on the back end when you go to order the actual core. So sometimes the other part of specifying a radiator core might be whether you've determined the radiator core is an OE core or an aftermarket radiator core. If you have a radiator that comes in and it's had an aftermarket radiator core installed in it, only experience is going to tell you whether or not that core is the right radiator core for that radiator. But there are some things that you can look for, like the way the tanks fit into the radiator, whether or not the original nuts and bolts look like and the gaskets are original to bolt together. There may be some telltale signs on an OE radiator, like tags on the radiator core that will identify it as an OE radiator core. Also, the way the tanks and the drop seams fit, the radius of the corners, all that stuff is going to match really well. So you should be able to get a feel of whether or not your radiator core is OE or it's an aftermarket radiator core. Once you determine that it's OE, then it's pretty simple from there to specify a radiator core, because you're dealing with the original equipment and you can usually match a radiator design. And I would impress upon everyone to, as often as they can, to duplicate the radiator core design that comes out of a piece of equipment, because there are fan airflow and fan calculations, cooling system calculations, that changing the density of the radiator or changing from flat fin to serpentine or vice versa could cause issues. Now, I know that in the radiator business, we're famous for wanting to improve and change designs, and most of us have been pretty successful at doing that. But for the purpose of today's presentation, I would impress on everyone to try to duplicate the radiator core design. What we did was we gathered all of the information from all the radiator manufacturers. We would print it out and laminate it, and then we punched a hole in it and put a ring through them, and we had every radiator core that was made in the United States that was available in this little binder or ring thing that we put together. And it made it easy to be able to flip through it and choose the core then that matched the application. And so I would recommend that you all do that also. So once you put together this preliminary information and you identify the core and you've received a quote from a manufacturer, now comes the time for the real work, which is putting together the actual measurements that you're going to order the core off of. Now, sometimes if you know the application, you may be able to look that radiator core up in a catalog in one of the manufacturer's radiator core catalogs. But keep in mind that those catalogs were made by radiator manufacturers who were receiving information from radiator shops, and they were cataloging that information. And so they had no way to ever verify that the information that they were getting from their customer was correct. They put together this information, and it's up to you to verify that those measurements are correct. And if you see something close, which I found out years ago, when you find something that's close, that doesn't necessarily mean that it's going to be an exact match. So most of the time, we just did our own measurements and we ordered everything special because there's no discounted price for part number radiator cores compared to special radiator cores. Here again, it's all done off of the amount of material that goes in to build the core. So let's get to measuring a radiator core. Here I have a, let's say, here we go. Radiator core specification form. Core date at the top, core manufacturer, core type, and then I'll read down. Core fin type, flat fin louver, flat fin bump, serpentine louver, serpentine no louver, square wave. Radiator core dimensions, core height, core width, core depth. For core width, it says fin only. So it's outside edge of the fin to outside edge of the fin. The core depth, rows of tubes, tube spacing. Also, that reminds me, I left one part out that's very important. Well, actually, a couple of things. When you're doing your preliminary measurements in order to get a price for a radiator core to quote your customer, you're not going to tear down that radiator or put any labor into that radiator, because if the customer declines the job, you don't want to have work and material that you might not get into that job that you might not get paid for. So I know we struggled sometimes with determining the thickness of the core. If it was really thick, how many rows of tubes were in that core? And then on top of that is what diameter were those tubes? If this thing is all in a welded frame, we're not going to cut the frame apart. So we used a camera like this, and we would take the end of this camera and we would go into the radiator. And I have a sample here, happens to be a plastic aluminum, but we would go into the hose connection of that radiator and we could count the tubes and see what the diameter of those tubes were, and count the rows so that we could determine that before we ever took the radiator apart. So we made an accurate quote. So sorry for leaving that out earlier, but that is very important because you can't get an accurate quote unless you know exactly what you're dealing with. So back to our core order sheet. Everything that you could choose on the radiator, like I said, rows of tubes, tube spacing, tube type, smooth tube, dimple tube, tube diameter, 3/8, 7/16, half, 5/8, 3/4, tube wall thickness, 4,000, 6,000, 8,000, 10,000, 18,000. I think also the dimple tubes are 7,000. Fins per inch, the fin gauge, fin material, copper, brass, steel, solder coated brass, solder coated steel, face dip, core side pieces, flat, C channel, box channel, GM, Ford, or other. And then on the back page here, we have top header, width, length, position, radius, universal. Some manufacturers offer it goes from almost square to a 5/8, and they call it like a universal drop seam header, but the corners are very square. They don't always work under side rails sometimes. And then you have drop seam, grooved header, pan header, flange height, bolt up header, gauge 050, 125, 156, number of bolt holes, header supports, corners, picture frame, entire header, header shape. Same thing with the bottom, it just repeats. Special instructions, and down here is crank box, live crank box, dead crank box, position of crank box, bottom header, in radiator core, refer to attachment for measurements. So this order form right here is pretty complete. So let's take our first core here, which is a soldered together radiator core. And let's fill out this sheet. So we've determined that, like I said, it's a soldered together. One side of this radiator core is high efficiency, and one side of it is a regular serpentine. So multi-louvered, high efficiency. This is a 1/2 inch centered serpentine. Some manufacturers call it a VT because the fin is in a V to the tube, and it makes a VT. The correct terminology is serpentine though. So since we're not going to put a plug in for any manufacturers, we are going to write the core type is going to be serpentine high efficiency. It's serpentine louvered. And the dimension of a radiator core is measured between the headers. So this radiator core is 15 and 13/16 in height. Now I'm going to measure in a different area, 15 and 13/16 there also. I'm going to measure on the ends because I want to make sure that the header isn't distorted. So sometimes if you have headers that have overhangs, they'll balloon, and you might have to come over to a corner where there's a side rail on a serpentine so that you can get an accurate measurement. So I'm going to go ahead and write down the core height, 15 and 13/16. The core width never includes the side rails or the side channels. The core width is from the outside of the fin to the outside of the fin. So here I have 13 inches, right on the money. So that's the core width. The core depth, we're going to use our little core gauge. We're going to slide that in, finger on the back side, like that. So it comes all the way in, touches your finger, make sure it's flush, and then you push in the gauge. And we're going to measure that. And this 4 row is 2.5 inches thick. So that's the core depth, 2.5. 4 rows of tubes. Tube spacing. There's where your calipers come in. You can use a tape measure. That's a 1/2 inch, or you can use a caliper. There are quite a few foreign-made radiators, but there we have 0.5. You can see 0.5. So tube spacing is a 1/2 inch. One of the other things that's of paramount importance is that when you're measuring radiator cores, always do it after they're disassembled. After you receive authorization from your customer, do yourself a favor, disassemble the radiator, because every time we had a mistake or something didn't fit just right, it was always because we tried to measure the radiator core, and especially on a solder together with the tanks on, thinking that we were going to save some time and get the cool order because the guys were too busy. And then what happens is the radiator core comes in, and then they're snipping and they're banging on the corners because the header's a hair too long or it's a hair too wide, and they're cutting the tanks and silver brazing them up, and it's a mess. I know it's more trouble on the front end, but it gives you a nicer, better job when you can disassemble the radiator, the old radiator, and just have the radiator core to measure. So do that. That was our policy. And the manufacturers that I've spoke to have told me the same thing, that when their customers make mistakes, it's usually because the radiator hasn't been disassembled. So the next thing that is on our sheet here is the tube type. It says smooth tubes or dimple tubes. In this case, it's smooth tubes. So we're just going to put a check. The tube diameter, now that I have the tube or the radiator is apart without any tanks, I can measure and I can say, oh, I have a 1/2 inch tube. So I would also recommend that you contact the manufacturers that you do business with and you ask for them to send you little samples of all the tubes that they have in stock so that your people know the difference between a 3/8, a 1/2 inch, a 5/8, and a 3/4 inch tube. So this is a 1/2 inch tube. Tube wall thickness, it's going to be standard. Most manufacturers are using around a 6/1000 tube for most of the radiator cores. 6/1000 tube is fine. Car manufacturers use a thinner tube, even maybe around a 4/1000 tube. But for this, we're going to pick a 6/1000 tube. Fins per inch. Now, this is where it I have this paper here that shows how to measure the fins per inch and the tube diameter. And I'm more than happy to share all of these papers with you. So when you start out at the peak of a fin and you measure 1 inch, when we measure this, we have 12 fins per inch. So that's the next thing that goes down. Fin gauge for a serpentine is going to be whatever the manufacturer has available. It's probably a 2/1000 or 3/1000 fin with a hem on it. So fin gauge for a serpentine would just be standard. And the fin material is copper. And then core side pieces. Well, we've got a box channel on this side, and we have a GM rail on this side. So we're going to say that we want a box channel. Now we get to the headers. So because I had this header made with all the different radiuses, 3/8, 1/2 inch, and 5/8, we're going to go off the 5/8 radius, which is the 50-cent piece. Also, this gauge here matches that. Everybody can see that. So we're going to say that the length of the header is 14 3/4. The width of the header is 3 9/16. And the position, it has a slight overhang. So we're going to say that we want a 5/8, 11/16 overhang front. Now, overhangs really doesn't matter if it's on the back side or on the front side of the radiator. If you have a top and bottom header that are the same and you have no crank boxes, no bolt holes, it's just a solder together. If the overhang's on the same side, it could be the front, it could be the back. It won't matter when you're ordering the core. It's just a matter of the way that the technician is going to solder it together, that he puts the overhang to the right side. But most of the time, we use a term called overhang front. So we'll be consistent and say that our overhang front is 11/16 at the top and at the bottom. That's pretty much the solder together. The flat fin radiator core is done the same way. Oh, and let me just say that the top header and the bottom header in this case would be identical, but not necessarily all the time. And then we would have any special instructions. And well, let's just run through it. So the radius was 5/8. Drop seam, grooved header, yes. Bolt up header, we don't have to worry about that. We don't have to worry about number of bolt holes. Header supports. Most of the time, we're going to go for corners, even on a CT, unless they punch ribs in the header, then it might be more difficult to get corner supports. But we would duplicate that then for the bottom header if the bottom header is the same. And then we have a complete filled out order sheet that we can fax or email to the manufacturer. And then I would also put on here the quote number that the manufacturer gave you when you originally called for the price, and of course the date, and that's it. So I think we're just about out of time. I wanted to get to the bolt together and do a bolt together header, but it looks like we have enough to cover for another webinar. So maybe next month's webinar, we can do bolt together headers, and we can also cover crankbox measurements. And I think that would be a nice follow-up for next month. Let's see, questions. All right, no questions so far. So if you are interested, I have the radiator core specification sheets. I also have bolt hole patterns. I have the crankbox measuring guide. I have a fraction to decimal conversion sheet, which we didn't get to because that'll come in handy when you're doing header templates. And then I have the fin per inch guide, if anybody would like that. You can email any of us at NARSA, mtaylor@narsa.org or staylor@narsa.org. Our email addresses are on the website, and I'll be more than happy to send you these documents. Want to thank TSM again for sponsoring this first webinar. I know your time is valuable, and we appreciate you signing up for this. The recording will be available on our website to our members only. So if you have any people that are in your organization that would like to watch it, they'll be able to access it through our website. Once again, thanks to TSM for sponsoring us. And we have another webinar, which is the After Treatment 101 webinar that's going to start in a few minutes. Oh, the 12 common mistakes. I have time for that. Let me find my paper. Dimensions are wrong because the unit wasn't disassembled prior to ordering. Header gauge is wrong, ordered light headers and needed heavy headers. We didn't get a chance to get to that today, the bolt together headers, which the caliper comes in handy for determining what size headers you have, or what gauge headers you have. So, you know, you can see here, you can use a caliper. I got an 050, and here I have a 0.1. The radius is incorrect. Overhangs are wrong. Bolt pattern is not accurate, which we didn't have time to get to that today. And we didn't have time to discuss notch corners. Baffles needed and not ordered, or placement of baffles is wrong. Failure to order full header reinforcements. When the order is read back to customer, the customer is interrupted and not listening. And then crankbox dimensions are not correct. One of the things that I would like to add is that we never ordered a radiator core verbally. That, to me, that's a recipe for disaster, because unless it's something really basic, most all the stuff that we did was industrial, truck, heavy equipment, and everything was almost a special. So we would invariably always have a piece of paper that got faxed or emailed, got a receipt for that, so we know it was ordered, the time and the date that it was ordered, and then confirmed with the manufacturer that they received it, so that there were no lost orders. You also have a record of what you ordered in case mistakes do happen, but you can always go back and refer to that. The other thing that we did was we kept every one of these order sheets that we did in a binder, and that binder had categories of dimensions, like 0 to 24 inches, 25 to 36 inches, 37 inches to 50 inches, and so forth. And so we would keep every one of these order forms, so that we would sometimes see the same types of industrial radiators come in, and we wouldn't have to reinvent the wheel. We could go back and pull out of the binder the order form and call the manufacturer, say, hey, on this date, we ordered this radiator core, we want another one just like it. And we would also, once we got it, we would put the invoice or the sales order number on it from the manufacturer that had provided that radiator core.
We do have some questions.
Huh?
We do have some questions, and we've got them snapshot.
Okay.
So
somebody asked a question, when you measure the header, is it on the inside or the outside? It is definitely on the inside. And that's why it's important to have the tank off, so that you can put that tape measure and get that good inside to inside dimension, whether it be the length or the width. Okay. Somebody said, is it a good idea to get the height measurement under the side rail before disassembly in case things wiggle around during disassembly? You know, that's from James Wilson. That's a very good point. Yes. When you take that preliminary measurement, you should get a good height. As long as that radiator hasn't been recored, and when they record it, you know, the header kind of got a little funky or whatever. If it's an OE radiator core, definitely, if you can take that dimension before it's disassembled, that definitely could be beneficial. What's the difference between copper and brass? The copper fins are going to be a normal application that's not around salt water or any kind of a corrosive environment, I think my good friend David Benvenu down Louisiana uses a lot of brass finned radiator cores, and I believe they get solder coated. Maybe David, if he's still with us, could chime in on that on a chat. So Admiralty brass would be in a corrosive environment where you don't want to go with steel because you give up too much on the efficiency side. So you wouldn't want solder coated steel. You would want brass plus steel in a corrosive environment wouldn't work anyway. So that's the difference between copper and brass. Huh? We got to go. Okay. Mark referred to a pin style. Okay. Let's see. On a drop seam, it's inside the drop seam to inside of the drop seam, inside edge to inside edge. Doesn't matter if it's a flat with a turn up like a pan header. Or squared off header with flanges, or a drop seam. The tank will sit in the same place. So the height of the tanks will be the same as long as you measure inside edge to inside edge. So that's all we have time for today. And like I said, the next one we'll get to bolting, measuring the bolt up headers and the drop, the crank boxes and notch cores. We'll talk about that in the next webinar. So thanks everyone, and have a great day. What's left? Oh, after treatment 101 is the next webinar. So they're telling me I need to get off of here so that we can log into that. So thanks again for your time, and look forward to seeing you again.